Good morning, everyone. Hello and welcome to this new presentation of our mobile mapping webinar series. My name is Bishoy Gerges, and I'm happy to introduce you to my colleague Miguel Parra, who will be presenting this webinar series presentation about the point cloud registration in TBC mobile mapping. So, Miguel, please go ahead.
Hello, Bishop. Thank you. And hello, everyone. As Bishop said, my name is Miguel Parra, and today I'm going to present this webinar series. Here in Germany today is a rainy day, so I hope you are having a better weather than us. And by saying that, let's introduce directly to the topic. So today's topic is point cloud registration in Trimble Business Center. And before to continue, I want to ask you if you are listening me well and the audio is okay for you. Just via chat, you can confirm if the audio is okay. It will be very appreciated. So as I said before, the point cloud registration is the topic for today, and we are working in Trimble Business Center. About myself, I'm support and training engineer for the mobile mapping solution in Trimble, and I hope that today's presentation will help you in most of your daily applications. Why this webinar series and why we continue with this point cloud topic? This is a continuation of our mobile mapping series that is meant to provide active communication channel to our customers and people interested in Trimble technology, especially in the mobile mapping system, hardware and software. The first webinar was about the aspects or influence of our accuracy on our data and how we can solve on how we can improve the accuracy that we achieve in our field. So that's why we continue now with registration, because it's a kind of interrelated topic. So based on the accuracy that we got in the field and based on some another input data, we can perform a point cloud registration to improve the accuracy of our data. I just want to check. Yeah, the audio is okay. I hope also my screen is okay for you. I think now my screen is there. Sorry for that. So we were in the introduction still, so not much things going on. And also very happy to be doing this demonstration or this webinar using our new release of Trimble Business Center mobile mapping module version 5.11, which you will see during the presentation that we have included a very useful and handy tools to improve and elevate the accuracy of our data. So for this webinar, we have this agenda. So I want to just point out what is the point cloud registration and what we needed. And based on that, we need to identify what are the requirements for this point cloud registration. Let's talk about some best practices that we could use during our workflow to improve or achieve the expected results. And to summarize all of this, we want to do it in a demonstration how to implement all of these concepts based on point cloud registration for the MX9 mobile mapping data. And at the end, we will also see some features, tools, how to evaluate and how to QC and QA our data and how we can present the results to our end users or our end customers. And of course, at the end of the day, we will do a recap on what we learned in the webinar. And the most important thing, we want to listen any question that you might have about the content of our webinar or additional information that you might be interested in. So for the question session, you can use also the chat box in the GoToWebinar tool. So you can use by now the chat to send us in advance any questions that you might have. So at the end of the webinar, we will have time to answer as much as we can. So please keep in mind that you have an active communication channel to us via the chat box. So then let's continue with our agenda. And as I said before, we want to make clear differentiation what is point cloud registration. Point cloud registration in principle is a special transformation between two data sets in which we are interested to calculate position and orientation transformation parameters between a reference dataset and a target dataset. By saying that, we should also know that TBC performs the registration based on datasets, point datasets, meaning that our reference dataset is a series of points for which we will extract the transformation parameters. Based on that, we will identify two different kinds of registration. If our reference points are extracted from one of the data sets without considering his accuracy, we will talk about the relative accuracy, relative registration. So meaning that we will have common points between the two point clouds, that is so-called the time points, and we will register one point cloud relative to another one. In the other case, if our reference points are points measured directly on the field and we know accurate the coordinates of these points, and the most important, this accuracy is higher than the data that we want to assess, we could talk about absolute registration, meaning that our transformation parameters will be calculated based on our GCPs against our target point cloud. Then, by identifying these two kinds of registration types, we should also know why it is useful for us and why our customers or our users of TBC and MX9 data will be using it. Basically, they will use to estimate the data accuracy of your project. At the end of the day, you will process your data and your contractors or your end user will be interested to know how accurate was the data. And not only by doing an absolute registration, you will estimate the absolute accuracy of your data. Not only knowing the accuracy of your data will be enough for you, you will also be benefit of the registration by having consistency in your data, meaning that no misalignments are between each run. So for example, each side of the row will be consistent in only one point cloud. And obviously, by having a good accuracy in your data and resolving the misalignment between them, you will also be benefit to be working with a different data sources, meaning another aerial application on another source of data for mobile mapping applications. Good. So knowing that, we will today be working in absolute accuracy, that I think is the most interesting topic for our customers to know the final accuracy of our data collected. So now I will talk about what we will need for the point cloud registration. So the requirements basically are our MX9 data, which has to be imported in TBC by using the post-process trajectory, and also by having prepared the scans. By prepare, I mean some pre-processing has to be applied in our raw data from the laser scanning. The first one that we are familiar with is the correction for the multi-time around correction. We also use the SBET file to georeference our raw data into real world coordinates. And here is the first new big feature that we introduced in our new, the current TBC release, that is a filtering option. So the filtering option will allow you to have a cleaner and nicer data to perform your measurements. Therefore, your results will be more accurate. Before to this release, we have been working with the default mode of measuring the generic point clouds, where no advanced filtering has applied. And most of our users in TBC has been working in this default application. Now we just expose the filter parameters so the customer can use those parameters to further investigate which filtering will be better or suitable for your own application. Additional to that, we have include two presets or customized filtering options, very specific for rail application and power line application. The parameters that we expose in this filtering that makes more clean data are the amplitude, reflectance, deviation, and range. And talking about a bit theory of the laser beam attributes, we will use, for example, the amplitude to identify, classify the laser beam by comparing the emitted pulse and the returning echo. Basically, the amplitude will give us the strength of the returning echo, meaning that we could identify different kind of targets, because this amplitude is depending on the target. So we can use, for example, in the power lines applications, use a certain range of maximum and minimum to identify, according with the reflectance of the power line cables, which reflectance or which response is suitable for these kind of features. Another important feature that we will use in the filtering is the deviation. The deviation we will see in the lower right-hand side of my screen. We will have the shape of the returning and emitted pulse, and the deviation is the comparison of the difference between the shape of the emitted pulse against the returning pulse by comparing the area below the curve of this shape. So meaning that if we have a difference between them, the value that we got, we will indicate us that in case of higher values, our shape is different that the pulse was emitted. Therefore, we can identify some additional features in our point cloud. This kind of difference between shapes occurs for targets that are hit by multiple beams at the same time, and that they are located in very slightly different measurement range. That is the case of the railway application, that the rail is always in a constant distance to our laser scanner, but the shape of the rail is very sharp, and the incident angle of our laser beam changes in a very small distance when we measure. So basically, if you are interested to perform any further filtering, you will play around with those 4 parameters. The next requirement that my personal opinion, I consider that is the most important, is to have a good quality control points, meaning that normally we receive a CSV file from our surveying team, and they said these one are our reference data, so please register my control points against, register your data against these control points. We should know before registering our data 2 things: the coordinate system that has been collected and the accuracy that those points has. By coordinate system I mean two things. If those are projected coordinates or geographical coordinates. And by accuracy, I mean that this accuracy should be higher than the data that we are going to register. So in that case, we need to use a very high survey points for control points. We cannot use same accuracy level to assess the accuracy of our MX9 data. So if that's not the case, we won't be able to establish the absolute accuracy in our registration. And very important to distinguish the height. Do we collect our control points with ellipsoidal height or orthometric height, and which is the reference for our elevation measurement? So this is also very important, and sometimes is regraded, or people they don't know exactly which coordinate system are referring to. So please keep in mind in these two topics about the control points. For those users that have been working with TBC, they might be also this document has been known for them. Is a well-documented best practice for mobile mapping with mobile mapping application for MX9, specifically for data capture, pre-processing, and post-processing. Here, I just want to highlight best practices for the point cloud registration. So if you allow me, I just want to show briefly what I'm meaning in this bulletin that you should have, and we will be happy to distribute it at the end of the webinar. So basically, they will tell you how you collect the data, very important in terms of the registration, that you should avoid in any case to do overpasses of the same lane or the same area in only one run, meaning that it is better to distribute or collect in split runs and double lane street if it's need to collect it twice. So meaning that you could have at the end of the day 2 runs per street, and you could perform run-to-run registration if it's needed, or if the misalignment is big. Another consideration that you should have the distribution of the control points. Here you will have a very detailed description how you should establish your control points. And also I will mention here the importance to have a reference while you're collecting the data. That's why now we provide the option to add a KML layer in your TMI software to identify where is your control points, taking into account when you are collecting the data. This is a very descriptive information about the control points that also will give you some ideas how to collect in terms of if you are using natural targets or artificial targets. So in the document, you will find a description of what will be the influence of having the right choice for the targets. And by here, I will make emphasis on that the best results are getting when we are using checkboard targets. Yeah. Okay, there are more details in the document, but we will be running out of time if we go into much detail. So I will be happy at the end of the webinar for those that doesn't have the document to share with you. So coming back to my presentation, I will jump into TBC to see how this absolute registration can be achieved. So the first step that you should have, and as I explained in my requirements, is to have a generated MX9 mission in TBC. By having a mission, meaning that you should have imported your MXDB, so the database that contains your data, and the SBET file. So meaning that you will be able to see at after the importation your trajectory file and the runs that you have collected if you are looking in the Project Explorer. In my presentation, I will be working in the run number 2, 3, and 4 for the purpose of the demonstration. Also very important here to identify the coordinate system that you'll be working with. So as you might know, our mobile mapping system was in UTM coordinate system, so you should be aware that this coordinate system has to be selected before start the importation. Then we necessarily need to save the project before we continue with any processing in TBC. So by having the mission in a new project in TBC, we can proceed from the mobile mapping tab to generate our scans, or by selecting the run directly in the Project Explorer to generate the scans. And here, as I explained before, we will see a new feature, that is the filtering. So here, to save some time in my processing, I will just generate the scan number 3. We will see that this run contains only the laser scanner and the panoramas view. In the next window is where we establish the new filtering option. So for this purpose, I will only use the default, but you can navigate and play around with the advanced settings to see the suggested parameters that we include for each kind of application, trail application and power lines. Here, I will continue with the default. And then in the next step is another new feature included in TBC, that we will have a better management of the trajectories file after registration. So by saying that, here we don't have anymore the name SBET file coming from the postpack project, but we have a better definition or better naming of each run trajectory. So for example, here by the name of the trajectory, I will know that I've been working with the run number 3. So by hitting the process button, I will generate my scans, applying the MTA correction, the filtering, and the georeferencing based on the post-process trajectory. To save some time, I want to close here, and I will open an already generated scan. I hope you are able to see my TBC screen with the new project. So now you should be able to see a project in black background where the run number 3 has been generated. So from here, we can start the registration process. The second and one of the important input data that we mentioned was the control points. So now this is our second step. 1 second, please. Okay, I will use the import format editor to import my control points. As I said before, normally we use this, or we receive the control points in a text file or CSV file, and we should be able to identify which information contains my text file. TBC allows you to see or to use an import preview to test which definition format should pass or should fit in your dataset. So if we look briefly in the content of the CSV file, we see that we have X, Y, and Z, meaning that this is easting northing definition. So we have these two definitions, point, easting, and northing, and we should define if it's elevation or ellipsoidal height. I know that my CSV file contains elevation height, so we should customize this definition according with the data that we have in case it's needed. So in case they provide definitions in TBC doesn't fit in your data, you should customize your own one. Another important thing here is to define the quality of the coordinate system. This quality means how TBC will use the coordinates of these points in the calculation of your parameters. In case in the processing you will be interested to change it, you will be able to change it only if you imported the points as control points. So here I'm ready to import my points, and in case there is any error, TBC will show me if I have an error during the importation. Another good practice is to create a separate layer for these points so you can manipulate in a faster way the points that you imported. So I will just create GCP point and maybe differentiate with another color the points. Also, good thing to do is to check the properties of the point to see that the coordinate has been applied correctly. So now I can start my registration. How we can start the registration? So now we have all the requirements in my project. So again, we can use the mobile mapping tool, selecting the run that I'm interested to register. And hit the button from the mobile mapping tab or right click register run. Here only 3 things to mention. You can, for a better manipulation, use the given name. So for the new generated trajectory for this run, the name is customized as you, so we can use, for example, registration, just to keep in mind that this is the new file that will be used to generate the scans. Registration type. In the previous version of TBC, we haven't had this option, and this is also a feature that has been for a while in the last release of TBC, meaning that we could identify or select different kind of registration. I would like to jump to my presentation to briefly show the difference between both of them. And by having a local registration, we will compute these transformation parameters that we mentioned at the beginning only and based on the control points, meaning that between the control points, the adjustment will be calculated by interpolation between the first control point until the end of until the last control point, meaning a maximum adjustment is applied in each point, but with an behavior that the adjustment goes to 0 after and before the first and last control point respectively. So this one is a very good application when you want to do a run-to-run registration in a local or particular area of your run. Also, for example, when you have a very pure GNSS conditions, you can adjust by a local adjustment certain part of the areas that you have in your projects. The other type of registration is a global adjustment. This global adjustment applies a uniform shift from the original run based on the computation in the control points. Here, the difference is like the initial segments of my trajectory and the last part of the trajectory after the control points are also applied. And this one could be very useful when you have a global shift, meaning, for example, I can think about when you have different reference in elevation, meaning that you capture or your control points has orthometric height coming from the leveling, a very accurate orthometric height, and now you want to register the data using orthometric height coming out of a GOA model, where those two accuracies are different. And the last one, of course, by the name we can guess that is the combination from the local and global. So the software will not only apply a maximum adjustment in each point, but also will extend the adjustment after and before the control points. So by knowing that, I will be working with global adjustment, and then the rest thing that I had to do is to add my control points into the control point panel. Here I could just select one of them. So let's, for example, say if I don't see my points, I can reduce the size of the points to see clearly the ID of the points. So in this area, let me choose, for example, 14. Here number 10, I will say. Here in the other side of the road, to have a better distribution of the control points, I should select an each side of the street. And here I like to include 43 and 42 to show you how to identify problematic control points. By selecting the points, I simply click the selection to control, and I will be able quickly to measure the points. As you see in the control points panel, you will be using all the points in horizontal and set adjustments. This you can control it by changing the accuracy of the coordinates by selecting control and unknown quality for the coordinates that you want to use or include in your computation. For example, if I don't want to use the point number 10 in the vertical adjustment, I will just switch to survey or mapping quality to exclude from the computation of the results. But let me do a complete adjustment, so I will switch back the quality of that point. So another feature that we have in TBC is the autofocus. Once I click in the control point, I will navigate directly to the point, and I don't have to scroll on pan that in the points. So let me start with the number 4. And by here, I will also introduce a new feature that we have in the registration module for TBC. That is called the Smart Picking tool. The Smart Picking tool is an option that will allow you to measure in the more accurate way and precise way the targets that you are selected in the point cloud. And here we also have 3 options. The first one is the default one that we have been working with, and this one has the limitation that you pick up points only in the rendering dots of the point cloud, meaning that if your point cloud density is not high enough to detect the road markings or the targets that you collect, you won't be able to pick up exactly the point that you are interested in. But for example, if we check the point number 4, I'm lucky to see that there is at least one point or one scan line directly in the corner of my point. So I can pick up, don't know if the screen is clear for you. Let me change the render settings. I think here is much better. Yeah. And also, if here I will increase the point size. So what I was saying is that in this case I was lucky, even though my MX9 data has a very high density, I might be able or not to see this exactly point in my point cloud. If that is the case, I will use the default option. So just by clicking in the corner that I want to measure. Once I measure, the software will calculate the residuals, comparing the control points coordinates against my picking target. But what about when I don't have the option to pick up directly in the corner? For example, here, if I'm interested to measure the point number 10, there are no any skyline directly in the corner of the road marking. And therefore, we have introduced a new picking tool called road marking that uses the intensity values of the point cloud to snap to the closest edge of a road marking. So this picking tool has to be started by selecting one of the points in the point cloud, and based on my selection in this point cloud, the software will calculate the closest, will snap to the closest edge of the road marking. Once I click in the point cloud, the software generates a validate picking window, which you could also see in a, let's say, bigger size, the selected area, and you could also use different rendering models to identify properly the selected target. You can switch between the gray scale intensity, but for me works good the color code intensity. As you can see, you can clearly identify that the software snaps exactly in the corner of the road marking, even though there is no skyline upon it. Once I'm satisfied with this coordinate, I just simply validate, and again, my residuals are being calculated in the target panel. So we were lucky here that the intensity values of my road marking was enough to identify the target. But let's see, for example, another point, 10, we already measured for 34. This one is also road marking, and what happens if I start again my road marking tool? I will see that is not so clear the information given by the intensity values of the point cloud. That's why I can also use this validate picking window to manually adjust the coordinates that are selected for this target point. Here, as I said, visually it's very difficult to see where I'm picking the point, so I will trust the software to see where the point was selected, and in the map view I can also edit the coordinates to see where the target is. I can see that based on the residuals, my northing residual is very high, so I could also manually edit it, and visually I can see that is very far from the position that should be. So if I manually edit the coordinates in north, I could reduce maybe 1 centimeter, and I will be reducing the residuals according with the addition of the coordinates. So let's say that this coordinate is 48 for the purpose of the exercise. And also we should see a consistency in our residuals that are in between of 3 centimeters range. Yeah, so then I will also include another 3 points. So let's say my surveying team did a mistake while measuring the points. So now I have 2 control points in the same road marking. But again, if I use my road marking here, my road marking tool, I won't be able to identify which one is the correct value. So I'm measuring the 43, and here I will see that it was clearly identified by using the intensity value. So I will accept this. But if I check my residuals, I will see that by using the tool, I get higher residuals. So I will expect that the 43 is not the proper control point. Here, my road marking tool is not helping me to identify the point, so I will introduce here then another picking option that is called Intersect Plane. Here again, you start the tool by selecting one of the points in the point cloud, and the software or my smart picking tool will generate a flat plane fitting between the point cloud where I've selected or where I click. So for example, I'm interested to have this intersect plane around this area, and I can see clearly or in better way where the target should be located. So as you see, there is no corner for this control point, and in somehow we should be able to locate the target in this position where no points from the scans are located. So this tool again, and also the road marking will allow you to get an interpolation where no points are registered in the scans. So here, if I select again this position, I will see that my residuals for the 0.4 are 44 are the same that the other ones, so are more consistent with the rest of my points. One thing that I forget to mention about the intersect plane, that the intersect generate plane give you a RMS how accurate was generated in terms of the information of the point cloud, meaning that the higher RMS will be generated in a ground place. Maybe you select a corner or an area where there is no flat surface. So well, we have now measured my control points, meaning we have the coordinates of the targets, and now we will be able to calculate our residuals. I just want to make sure that we have all the points measured and included, and now I will compute the adjustments. So the computation process will allow me to establish some residual adjustment after the computation. So meaning that higher adjustment will give us an indication of probably wrong control points or wrong measured targets. Here, if I see my adjustment residuals, I can see that for most of the points I have around 1 centimeter. Point number 10 is already 2 centimeters. 34 is okay. 43 is in the range of 1 centimeter. Yeah. 43 is 15 centimeters, so it's higher in east and north. Let me just move my screen to see the residual for 44 is around also 1 centimeter. What happens if I remove the highest or the highest error? So I consider that 43 is my outlier. So I can again compute only by 4 points by unchecking the point. And again, we will get a second set of adjustments. And if we are happy with this adjustment, we can proceed to apply this registration. This analysis from the residual, you can also do it by generating the point cloud, the point 10, 14, 34, and 44 to generate the point cloud point comparison report. So here, if we see our residuals, all of them now are around millimeter and 1 centimeter error. And this information is given also in the comparison report for further analysis and to include or exclude points that you are not happy with the residuals. Once we said, okay, this computation I'm happy with, I can apply this. So I want to also show you the properties of my current mission. So my current mission has an active trajectory file coming from postpack, and once was compute the adjustment, a new SBET file was generated only for this run. And here I will apply the results, and this new SBET file will be taken into the active trajectory. And based on this new SBET file, I can generate my new or update the scans based on the registration results. And by updating the scans, I just need to select the update the scans button, click next, and make sure that the trajectory is the one that we call trajectory registration, in case we customize the name of the trajectory, and we will hit the button process. At the end, you will get a registered run, and you could check the quality of your results by using the tool Limit Box. Limit Box is a very quick way to check the control points. So for example, I will check one that we measured that was 14. And we can see here vertically, we will see the difference between, this is the point 14, and we will see that the green line is the generate or a register scan, and the red one is my original run. That one is in terms of vertical results. And if we look in a top view of the point, and by using the gray scale intensity, we can see also position of the raw position of the scan data, very accurate and in the corner, so exactly where we select the target and before the registration of the target. So the adjustment was good in this point, but what about a point that we didn't measure? For example, we have here 19. So let's see how is the results in 19. 19, we are looking at, maybe increase the point size. We are looking at the scans without registration in horizontal, and if we switch to the register scans, we will see the new position of the scans. That is the validation of the points visually, and you also could use the option to export your registration report to have the statistics of the new trajectory file. That basically will include adjustment before, residual before the computation and after the computation, in elevation, is north and elevation. And if we see here, the highest error that we have is more or less 3 centimeters. The report also will tell you which points were included, which type of registration was applied, the type of point that you use, so you use a control point, and of course, the accuracy that you achieve at the end of your adjustment. Yeah. This is how you could check the results of your registration, and after that you will be able to export your data into TMX or another third-party software. And by that I conclude the practical way of do a point cloud registration. Before finishing, I wanted to summarize the key points that we learned or the takeaway for you from this webinar, and I hope you have enjoyed and learned some good practices to do your point cloud registration. So basically we understood what is point cloud registration and why we need to do it, and the most important, how you could benefit to use Trimble Business Center to improve the accuracy of our mobile mapping MX9 system. We also see some new nice feature from filtering to generate clean data that will improve the measurements of your work. We also see the importance to have a very accurate data, meaning accurate GCPs to correct your data, and also the new picking tools that we include in the smart picking tool, and some useful ways to validate the data that you get out of the registration. So now we reach mostly on time the end of the webinar, but I guess we still have some questions, some time for questions. If you have, that one will be a good time to answer some of the questions. Meanwhile, I will remind you that our webinar series will continue mostly every month, so you should be tuned with our any channels for mobile mapping, community, imaging download, to be informed about the topic and the date where the next webinar will be take place. So let me check our incoming box if we have any question.
All right, thank you, Miguel. We have a couple of questions here, so I will start by first question we got: how to georeference the point cloud so that it overlaps with the real workplace. I guess this is what we covered already in the presentation today. Another couple of questions regarding the presentation and the documents that we shared today. So I guess this, as usual, will be sent to everybody after the presentation, after the webinar. So you will always get an email with the recording. And we'll also make sure to include the presentation and the document that we shared. We have another question regarding vertical ground control points. Is it possible to place my targets in an empty space somehow? I guess that was also covered, and we've seen and we have shown you all how to pick points even if they do not exist on the point cloud, and you can pick them from any view, not just from planar view or 2D view as was in Trident. So that's not a problem here. Export times of point clouds with GeoEd. Export times, yes, indeed, they are longer because all the coordinates are transformed to the GeoEd, to the new GeoEd. So there are some complex computations running in the background, and this indeed increases the export time. So we don't have a hand in this one, except that we can say in TBC it is way better than Trident because TBC can utilize all of your PC power, basically. So in other words, the faster PC you have, the more cores you have, the more threads you have, the faster it will be. Another question, can we output and optimize 3D mesh from point clouds using specified dimensions like 1 meter by 1 meter? You could use any existing tools that you have in TBC to generate a mesh or to generate a DTM or generate any sort of surface. So anything that you have in TBC that could work on point clouds, you could indeed use it on the point clouds that we have from the mobile mapping data. Question, which software should I use to do the georeferencing? TBC.
The presentation was about TBC.
Yeah. Is there any paper or explanations on how the relative positioning between the scans or runs work? That's a good question. Miguel, do you want to answer this one about relative registration? So, okay, basically, yeah, go ahead.
Yeah, for the relative registration, most important thing is that you should be able to identify the tie points, meaning both of them should be visually and easily identified between the two runs. Meaning that we also have an adjustment and interpolation in this computation, you should distribute it equally between the scans.
Yeah, so basically we cannot or we do not have a specific, okay, I think we're getting questions that we're having an echo here, so because I'm sitting next to Miguel. Miguel, could you mute yourself, please? Thank you. Basically, we don't have a dedicated tool for relative registration, but the workflow is simply a workaround, and that will be basically you would make sure that you have one scan that as a reference. So let's say you have 5 scans passing the same area and you want to relatively register all of them together. You'll assume one of them is the reference, and from that reference scan, you'll extract your control points. So you'll just extract coordinates of points from the point cloud, and you will use these control points as control points input for the other 4 scans. And this is how you could do relative registration. So we don't have like plane matching or object detection that could detect corners or surfaces from 2, 3, 4 scans together. It is coming, but we don't have this now. So the workaround is to start extracting, making your own control points from one scan, and then using these control points as a reference for the other one. So I hope this answered this question. Now, moving next, we have, can we output the EG topoless, the cuts from the corridor? I'm not sure I got this question. Miguel, you know what this means?
EG?
Yeah.
And I'm not sure about what does EG mean.
So, if you could just please maybe repost your question. Okay. So another question was saying, can you directly export your registered project together with your panoramas to Orbit? Yes, we can indeed export everything. So if you would go to the export options, you would basically take you choose which runs you export, and it will export the latest available scan. So, and in that case, if the latest available scan is the registered one, then indeed you will have the registered data and all of them together with the panoramas, also planar cameras if you would have. Any options to combine point clouds? No, from the mobile mapping export options we have, we can just export, if you would like to export to TMX format, you could just export the last files per run. But Miguel, do you have other opinion on the last export itself? So in the last export of TBC, it might be possible that you could combine multiple scans together, just like any TBC workflow. But because we're more focused on the mobile mapping export, all the available options to export data to mobile mapping formats, to other third-party software like TeamX or Tupodot, for example, we use one last file, or let's say one export file per scan, so we cannot combine the scans together. Okay. Another. Yeah, Miguel, please.
Yeah, but I think also I don't know if they're interested to merge the scans in TBC. If the question is to combine the point clouds from different sensors in TBC, or while exporting to a third-party software. So as you said, it's very important that we are working in mobile mapping application. We are interested to work as a whole data set, so meaning that we will be able to have a accurate point cloud, but also to have the information coming from the images. So if we are exporting or wanted to merge or combine different sources of point cloud, we will lose this quality to have mobile mapping data.
All right. So I think we have no more questions here. So maybe a couple of seconds, last chance, if anyone has any other questions would like to post. All right. So I hope you enjoyed the presentation for today, and it was very nice to see you all here, and it was very nice to see lots of people having interest. And I think we will, as Miguel said, we will keep continuing the presentations and the webinar series in the future. So we will keep you posted on the new webinar. And of course, you will get the link to the video of this presentation and also all the supporting documents. So thank you all for joining, and wish you a lovely day or an evening, depending on where you are. And hope to see you in the next one.
Yeah, from my side also, thank you for your attention to be here with us in this webinar, and looking forward to see you in the next webinar. Have a good day.